So in this video, I'm going to be talking about identifying and writing equations of perpendicular lines. One of the things I need to do first is to define a perpendicular line. So I'm going to go ahead and write some information and draw a picture of perpendicular lines. So a perpendicular line, I'm going to write over this like this. Perpendicular lines are two lines that intersect. And if you were here in class the other day, we did these same notes. This is just a review. So two lines that intersect. We know that when they intersect, that they make, so at point of intersection, they make a right angle. So a right angle, I'm hoping you remember that, a right angle measures 90 degrees. Okay, what else do I know about perpendicular lines? Well, there's something about their slope. Because remember, parallel lines have the same slope. Well, the slope of these lines are, so the slope of the perpendicular lines, they're considered inverse reciprocals of each other. In another way to say it, the slope of perpendicular lines are opposite / reciprocals of each other. They are also considered inverse reciprocals. I've even heard people say negative reciprocals, but I worry about that term because when I think of a negative, I think of a negative number with a negative sign in front of it. And that's why I like inverse reciprocals, because if I've got a negative 1/4, then the inverse reciprocal, so the inverse of negative is positive, and the reciprocal of 1/4 is 4. So these are inverse reciprocals. Okay, I could even say positive 3/8. And what is the inverse reciprocal? The inverse reciprocal of that would be negative 8/3. One thing I want to remind you, please, is that when I have 3 as a whole number, then when I take the reciprocal of that, you need to remember that there's always a denominator of 1 for any whole number. Therefore, if I have 3 as a slope, then the inverse reciprocal would be negative 1/3. So that is just what a perpendicular, those are the properties of perpendicular lines. Okay, so now let's take a look at identifying parallel and perpendicular lines. So one of the things you need to remember that whenever I'm identifying anything with regards to parallel and perpendicular lines, what did we just learn about? Well, we learned that the slopes, what should I compare? Well, I learned that the slopes are different. So for a parallel line, so if I'm comparing or looking for parallel lines, I'm looking for the same slopes. Okay, and if I'm looking for perpendicular lines, so I'm going to write perpendicular lines, I'm looking for inverse reciprocals. Alright, so let's go ahead and take a look. We're given 3 lines, line A, line B, and line C. We're being asked to compare or to figure out what lines are parallel, what lines are perpendicular. So in order for me to be able to do that, I need to compare their slopes. Well, look at line A. Line A is in a great form to be able to get my slope. So one of the things I want you to note is that whenever I'm comparing slopes, I want to make sure that it is in the format of y is equal to mx plus b. That's the best form that I can compare slopes in. I can put most equations in that form. So let's go ahead and take a look. In line A, I've got y is equal to 4x plus 2. Therefore, from my equation, I know that my slope is equal to 4, right there. So there's my slope of line A. Now I'm going to look at line B. Line B is not in y is equal to mx plus b. In fact, it's in a reverse standard form, or it's ax, it is in standard, ax plus by is equal to c. So this is standard form, and I want to turn this into y is equal to mx plus b. I can do that by using my equation, or solving equation skills. So I'm going to go ahead down here, and I'm going to write x plus 4y is equal to 3. And in order for me to be able to get it into y is equal to mx plus b, I'm going to take x away from both sides. When I do that, I am left with 4y is equal to negative x plus 3. I'm going to continue to solve and get y by itself by subtracting everything by 4. When I do that, I'm left with y is equal to, and one of the things I want you to remember, that there is a 1 that sits in front of the x. So I am going to write negative 1/4 x plus 3 over 4. And right there, in that format, so I know that my slope is negative 1/4. So I'm going to come over here, and I know for slope for my line A, in fact, I'm going to write it right here. So line A, my slope is 4. For line B, I change colors, and I'm going to go my slope is equal to negative 1/4. Draw a box around it. And now the only other thing I have to do is I've got to do line C. So let me write line C, and I need to go in and I need to calculate my slope. So again, I'm looking at that line C. I'm going to notice it is not in y is equal to mx plus b. So I need to do some manipulating. So the very first thing I'm going to do is I'm going to add 2x to both sides. I know that that goes away, and I'm left with negative 8y is equal to 2x plus 16. Okay, remember, I need to get y by itself, so I'm going to actually divide everything by negative 8. Notice I'm showing the division against all those terms. So I'm left with y is equal to 2 over negative 8 is negative 1/4 x. And 16 divided by negative 8 is minus 2. So again, I'm looking for my slope. So I'm going to draw a box around negative 1/4. I'm going to come over here, and I'm going to write my slope for line C is negative 1/4. So it asked me to determine which of the lines are parallel or perpendicular. So I'm going to take the easiest statement to write would be that line B and line C, if you'll notice, their slopes are the same. Therefore, I can say the lines are parallel. So I'm going to say line B and line C are parallel because the slopes are the same. Right, now let's go back in and take a look. And now I've determined if they're parallel, so now let's look at perpendicular. So I'm looking for inverse reciprocals. So I want you to look at 4. And if I take the opposite or the inverse of 4, I get negative 4. And if I take the reciprocal of negative 4, I get negative 1/4. So you're going to notice that those are reciprocals, inverse reciprocals of each other. Therefore, I can state that line B and line C are perpendicular to line A. How do I know that? Because they are inverse reciprocals of each other. Okay, so there you go. So now, in the next example, it's asking us, in example 4, to write an equation of a perpendicular line. So the first thing that you need to remember, that when I am writing an equation, I want it in the format of y is equal to mx plus b. The other thing you need to remember, that when I am talking about a perpendicular line, that I'm looking for the slopes to be inverse reciprocals. Okay, so now let's take a look and see what our example gives us. It says to write an equation of the line that passes through this point, negative 3 and 1, and is perpendicular to this line of y is equal to 1/2 x plus 3. So, what do you need to do first? What do I need to find? Well, step 1. I personally, what I would do first is I would label negative 3 and 1 as a point x1, y1. So I'm going to go negative 3, comma 1, and I'm going to label it x1, y1. Okay, and I like to just get that out of the way. Okay, what else do I know or need to do? If I'm given this word perpendicular, I need to know that my slopes are inverse reciprocals. So currently, right now, my slope m is equal to 1/2. And if I'm going to write a perpendicular line, then my slope is going to be the opposite or the inverse of positive 1/2, which makes it negative. Okay, so negative 1/2. And now I'm going to take the reciprocal of 1/2. So my slope is going to be negative 2. So what I did was, I took 1/2 and took the inverse, or the opposite of it. So that became negative. And then I took the reciprocal, which means basically I'm just going to flip this upside down to be 2 over 1. So therefore, I just get rid of the denominator of 1 and it just say negative 2. So I was able to find 2 important pieces of information. I have my point and I have my slope. So use what I found in step 1, and what else can I find? Well, we could use the point slope. Y minus y1 is equal to m times x minus x1. Why did I use that form? I used it because I'm given the point of negative 3 comma 1, and I'm given this, and I know the slope, and my m is equal to negative 2. So now all I have to do is substitute the values in. So I'm going to write y minus 1 is equal to negative 2 times x minus 3. Go ahead and simplify right here. So I'm going to write y minus 1 is equal to negative 2 times x plus 3. I'm now going to go ahead and distribute right there. I'm going to write negative 2x minus 6. All right, y minus 1. Now I'm going to add 1 to both sides. When I add 1 to both sides, I get y is equal to negative 2x minus 5. And that is an equation of the line that passes through negative 3 comma 1 and is perpendicular to this line. I know that it's perpendicular because when I look at the slopes of 1/2 and negative 2, those are inverse reciprocals of each other. So in example, or on the back page, so I was on page 21. Now on the back page of 22, you have two practice monitoring progress problems. Problem number 3, where you're determining which lines are parallel or perpendicular. And in practice monitoring progress number 4, where you're being asked to write an equation of the line that passes through this point and is perpendicular. So it's just like the examples that we just did. So I'm going to go ahead and pause the video, work through the problems, and put the answers, and then you should double check your work to make sure that you agree. So you can see what I did for the practice monitoring progress. I had to first move or manipulate the equation for line A and C into y is equal to mx plus b. So noticing that I needed to subtract 2x from both sides, which left me with negative 2x minus 3 is equal to 6y, dividing everything by 6, and then simplifying as I did that, which left me with negative 1/3 x minus 1/2. I then indicated my slope was negative 1/3. So that was my slope of line A. Line B, it was a straightforward y is equal to mx plus b, so I was able to get my slope of 3. And for line C, I needed to again manipulate, and I got a slope of 3 for line C. So when I did a comparison, I looked at all 3 slopes, and what did I notice? That line B and C have the same slope, therefore the lines are parallel. And then I went one step further and I looked at that line A was actually the inverse reciprocal to line B and C. So therefore I knew that line A was perpendicular to line B and C. Or I could have said that line B and C were perpendicular to line A. It doesn't really matter. It means the same thing. So then in example 4, we were supposed to write an equation of the line that was passing through a point of negative 3 comma 5, and I was being given that it was perpendicular to the line of y is equal to negative 3x minus 1. Well, I already knew my point, so I identified that as x1, y1. And if I'm given a perpendicular line, I know my original slope of this line is negative 3, and if I'm talking about a line perpendicular, I'm going to take the inverse reciprocal. So that means I'm going to go 1/3. So I was able to indicate that my slope was 1/3. So I went ahead and used point slope. Worked out really nicely. So when I multiplied and distributed, I got that y is equal to 1/3 x plus 6. The very last thing that you should do for this lesson is make sure that what do you know about the slopes of vertical lines? Vertical. So now I'm all of a sudden asking you to think about vertical and horizontal lines. So I'm just going to draw a picture here. We know that that's a vertical line. What do we know about their slopes? We know slopes are undefined, right? They're undefined. What do I know about horizontal lines? They have slopes of 0. Okay. So think about, when are vertical lines, right? Vertical lines. When are they perpendicular? Well, think about the origin right here. We've got a 90 degree. So you need to be careful that vertical lines being perpendicular, you'll notice that we often draw them on a side note, on a slant, on purpose, because your slopes are undefined here. So I just want you to think about that. That's a special case. All right, so that was lesson 4-3 on parallel and perpendicular lines. Your test is going to cover 4.1 through 4.3. That is why I made these videos, in order to help you. All your homework leading up to this point has been about writing equations of parallel and perpendicular lines, being able to use the point slope form, being able to identify and write equations of lines. So pay close attention on homework. The most important thing I need you to remember, that if it's asking you write an equation of the line, we're writing it as y is equal to mx plus b. And I can get to y is equal to mx plus b. I can get there from this point slope form of y minus y1 is equal to m times x minus x1. So again, if I can get the slope of a line, how do I get the slope of a line? By taking y2 minus y1 over x2 minus x1, right? This is how I calculate slope. Once I get slope, I can put it in right there. If I'm able to calculate slope, well, then I'm given points. So all I need to do is grab an x1, y1 and plug in, and then I'm able to then get to y is equal to mx plus b. So on Thursday, we're going to practice, do a practice test, and then hopefully that's going to help solidify some of your learning, and then Friday, take our test.